Hello everyone, welcome back to Vast Data Talks. In today's video, we are diving into something extremely powerful for anyone working with Snowflake, analytics, or AI-driven applications. We are going to walk through how to build an end-to-end Streamlit in Snowflake application powered by Cortex Analyst. If you ever wanted to let your users ask natural language questions directly on top of your structured data and get high quality SQL generated behind the scenes, then this tutorial is for you. What makes this really exciting is that Cortex Analyst works directly with semantic models. So instead of writing complex SQL or stitching logic together manually, you can define business friendly concept once and allow the system to automatically reason over your data. And with Streamlit in Snowflake, we can turn that intelligence into a fully interactive in-database app. By the end of this session, you'll learn how to configure your semantic model, call Analyst via REST API, enhance the responses using Cortex Search, enable joint support for star schemas, and even multi-turn conversational analytics. Basically, we are building a smart, production-ready conversational analytics application right inside Snowflake. So stick around because this is one of the most practical and high-impact Snowflake AI workflows you can implement right now. In this demo, we'll build a semantic model over a sample of financial data and a Streamlit in Snowflake application with a conversational interface to the Cortex Analyst. So this is the sample screenshot that we'll be building in this demo, where you can see it can ask like what questions I can ask. It gives a basic explanation of the semantic data model and few follow-up questions. For example, the daily cumulative expenses in 2023 December, or for example, for each month, what was the lowest daily revenue, on what did the lowest revenue occur. And on the left hand side, we can see the chat history as well and the semantic model which was selected for this Cortex Analyst. So now let's start building the application. Now let's set up the Snowflake environment. To set up the Snowflake environment, you need to log in into Snowflake. For that, you can go to app.snowflake.com and you will be asked to enter your username and password. Once you enter those credentials, you will be navigating to this home page. Yeah, for this demo, we'll be creating a demo database schema and a stage. To create all of this, we'll be using the SQL statements. To execute and write those SQL statements, you need to create a SQL worksheet. Basically, that can be done by on the left hand side in the menu, there's a plus icon. If you click on that, you'll get an option of SQL worksheet. This will open a new SQL worksheet where you can type your commands and execute them. Now let's see what are all the commands that you need to execute for this demo. The first is we start by switching to the security admin rule. This gives us the required privileges needed to create and assign new roles. To run any particular command in this SQL worksheet, what you can do is you can just highlight it, and at the top right, you see this run icon. Once you click on this, you'll get a status called statement executed successfully. Next, we create a custom role called Cortex user role. This role will represent the users or application that needs access to the Cortex Analyst resources. Then we grant this Cortex user role to the built-in Snowflake database role called the Cortex user, which provides the necessary information to interact with the Cortex features. After that, we assign the Cortex user role to the specific user. In this case, it will be me, enabling them to work with the Cortex Analyst environment. Now, we switch to the sysadmin role, since this role is responsible for creating databases, schemas, and compute resources. We create a new database called the Cortex Analyst demo. This will contain all the tables, semantic models, and the application assets for the walkthrough. Inside this database, we'll create a schema called the revenue time series, which organizes the data for our time series revenue analysis. Next, we also set up a warehouse called the Cortex Analyst warehouse, where we set the size as large, and we also enable auto resume equal to true. So it instantly wakes up when needed. And we also set auto suspend to 60 seconds, basically 1 minute, to avoid unnecessary compute cost. So this is the process of creating the database, schema, and the warehouse. Next, basically the role that we had created, the Cortex user role, we're granting the permission to use and operate on the warehouse that we had created, that is the Cortex Analyst WH. So this ensures that the users has ensures that the Cortex user has the full control to create and modify the objects. Yeah. Moving on. Next, we'll use the role Cortex user role that we had created. With all the infrastructure in place, we switch our role to the Cortex user. We select the warehouse, we select the database, we select the schema. Then we create a Snowflake stage called raw data. This stage basically acts as a landing zone for important files and feeding data into the warehouse. Basically, you will be uploading all the we'll be creating multiple tables. The what kind of data, basically like the sample values that should be going into those tables, we'll be storing it in the staging folder. Also, the semantic model that we'll be creating, basically the YAML file or the JSON file, will also be uploaded in the staging folder. The Cortex analyst will have access to the staging folder, and based on the semantic model that is available in that stage, it will take that to generate the SQL queries. And we are also setting the enable equal to true. So basically, we are saying that we allow Snowflake to automatically track and manage file metadata, which makes ingestion easier. Now, we'll be creating the fact and the dimension tables. So our first table is called the daily revenue table, where we have fields like date, revenue, or cost of goods, services, forecasted revenue, product ID, and region. This is the SQL or the DDL query that is required to create this table. Next, we create this product div, which will have the product ID and the product line. And the final table in this is the region dimension table, which will have the region ID, sales region, and the stage. All these are the three tables that we'll be primarily using for this demo purpose. That is the daily revenue, product dimension, and the region dimension. Once we execute all these three SQL statements, on the left hand side, you can see under the objects, or if you do not see, just click on the refresh button. You can see we have a Cortex Analyst demo database created, under which we have the revenue time series schema created, under which you can see the different tables, stages. So under table, you can see the three tables that we had just created, the daily revenue, the product dimension, and the region dimension. And under the stage as well, you can see the raw data stage. Next, we'll look at how to upload the data in these three tables. So for that, if you remember, we said that we'll be doing via a staging folder. So just click on the raw data. And once you hover over it, you will see this pop-up, open stage details in a new tab. This is one way, or under the left hand side, there's a menu called Database Explorer. Click on the Database Explorer. Here, similarly, Cortex Analyst Demo, public time series schema. Under the series, click on the raw data. Yeah, in this stage, we'll be loading all the CSV files basically for the three tables that we have, the daily revenue, product, region, and also a semantic layer. We'll see what are the details of the semantic layer. First, you can upload it by clicking on the plus icon that is there on the top right corner. Once you click on that, you can browse the files and you can select the different files that you want to upload in this staging folder. You can select the schema and the stage. If you have multiple stages, if you want to load a particular file into a particular stage, then you'll be able to select that. And once you have selected, just click on upload. And you'll be able to see all those files available in this staging folder here. Now that we have our files loaded into a staging folder, we'll see how to get this information loaded into our tables that we had created. So there are two ways to go about it. First is on the left hand side, you see a menu under the Database Explorer. Click on that. Go to your corresponding DB. That is the Cortex Analyst demo for this purpose, revenue time series. And you can see the table. Just click on the table. And at the top right corner, you have the option of called load data. Once you click on it, you will be able to select the CSV file. You can manually upload the CSV file Here, click on next, and you can able to see which field is mapped to what from the Excel and the table that we had created, so that you can verify. For example, date is mapped to date, revenue is revenue, cost of goods service is tagged to cost of goods service correctly or not, and then you can click on load. Once you click on load, automatically whatever the number of rows that were present in your CSV will get appended into this table. Here you have the option basically like do not load any data or case sensitive, what type of file format is it, those kind of information is available. Yeah. So once you load the data under the data preview, you will be able to see the sample information, basically like the date, revenue, different fields, what are the available information that is present under this table. The next way is doing via a SQL query. Let's open a SQL worksheet again. We'll see how to load it via a SQL query. So yeah, this is the SQL query. Basically, we are saying copy into the Cortex Analyst demo, which is our database name. Revenue time series is our schema name, and this is our table name called the daily revenue. From raw data, raw data is name of our stage files. Basically, like this is the CSV file that it needs to consider for appending the data into the daily revenue table. Here we are providing some information, metadata information, like for example, the type of the file is CSV. Skip header equal to 1 means consider the first row as column names. What are the field delimitators and all the kind of things we are mentioning here. And once you execute this query, so automatically it will pick up this file, basically the daily revenue file from the raw data stage folder, and it will copy into this table, daily revenue table. So these are the two ways using which you can load the data into a table using in Snowflake. Now that we have the database created, schema created, tables created, and the information or the data loaded into these tables, now we'll see how to create a Streamlit application inside Snowflake itself. So similarly, go to your left-hand side menu. Under this projects tab, you have an option called Streamlit. Just click on that. Make sure you're using the role that we have created. That is the Cortex user role. If you see any other role, just to hover over this and you'll be able to select the appropriate role. Yeah. Once you have selected the appropriate role, on the top right option, you have a option to create the Streamlit app. Click on that. Yeah. You can give the title as anything, for example, demo video. You can select the location where do you want to store it. That is the database name, Cortex Analyst demo. And you can select the schema under which that you need to load it. That is the revenue time series in this case. And we have created a warehouse, right? Cortex Analyst warehouse. So just select that and click on create. So Snowflake automatically creates the environment.yml file, the warehouse and all are starting. So once it starts, you'll be able to see the output of whatever the script that is there on the right hand side. And here you'll be able to see all the different application files that you have. For example, the Streamlit app.py, which is currently running. This is a sample Streamlit application which Snowflake creates on its own. Basically, it displays the number of hi-fis based on the quarter in a bar chart as well as the table. You can increase the number of hi-fis and automatically this charts corresponding charts and the table will get updated. This is the You can make changes to this code in this section, and once you have made changes in this code, when you click on run, automatically this output will get updated. For example, I'm just saying example Streamlit application using Cortex Analyst. I'm just changing the title. And once I click on run, you can see the change that you have made is reflecting here. So this is the basic application which Snowflake provides by default. We can make the changes in this code and see the output. Now let's see how we can integrate Cortex Analyst and use our tables that we had created and the semantic layer file that we use for this demo purpose, and see how we can create a user interface where the user can ask the questions and it will generate the SQL queries and provide us the output. See the semantic model that we have created for this demo purpose. So basically, semantic model is very important for Cortex Analyst because in this it will contain all the different types of tables that we are using. What are the different types of columns? What are the measures? And any KPIs that we can define? What are the relationships between multiple tables that we have? So having a good semantic layer is very important for Cortex Analyst to perform really well. So for example, we are just giving a name for this semantic layer called the revenue. Under this, we have a section called the tables. For example, our first is the daily revenues table. We provide a brief description, daily total revenue aligned with daily cost of goods sold and forecasted revenue. Under the base table section, we highlight what is the database where this table is stored. In our case, it will be the Cortex Analyst demo. Schema will be the revenue time series, and the table is called the daily revenue. These are the primary key columns, and these are the time dimensions. And you can and measures. For example, we have a daily revenue where the description goes as the total revenue for any given day. Synonyms is nothing but basically like the different ways in user can ask a question, and based on it, like this field should be targeted or not. For example, if sales or income is mentioned, then the daily revenue field should be used. So this is a way for us, by providing synonyms, just this is a way for us to guide the Cortex Analyst to select the appropriate field. And we can also provide default aggregations like sum, where, for example, if daily revenue is there, it should by default give a sum. Next, you can create some KPIs or something like that as well. For example, daily profit. This is not a column that exists in our table, but we are creating in the semantic layer. Just the description is profit is the difference between revenue and expenses. And the expression we are giving is it's the revenue subtracted from the cost of goods services. So this is kind of a KPI that we can provide. Though this column does not exist in the physical table that it is there, but it is creating it on its go. Yeah. So similarly, this is the next table. That is the product. What are the primary column, primary keys, the different dimensions and measures. Similarly, we have it for all the three tables. Yeah. Finally, next is the relationships, where you define how all these three tables are connected via. For example, the first relation is the from revenue to product, where the left table is the daily revenue and the right table is the product. We also define the relationships columns, basically the join conditions. Both these are joined on the product ID and the join type. It can be left outer, right join, inner join, and all those kind of things. And what is the relationship between these two tables, many to one. The final section is the verified query. For example, if you see a particular query, the Cortex Analyst failed to respond correctly. So in that case, to improve the performance of Cortex Analyst, you can enhance this semantic layer by adding something called as a verified queries. For example, the question that was asked by the user is daily cumulative expenses in 2023 December. We saw the Cortex Analyst did not answer it correctly. So in that case, you can give a sample, the correct SQL query that the Cortex Analyst should have generated for this particular question and add it as a part of the semantic layer. So next time a question is asked similar to this question, like cumulative expenses, then the Cortex Analyst will refer to the SQL query that was created and will generate a correct response next time. You can add as many number of verified queries as possible. So this is the semantic layer that we had created. Basically, it contains the information of all the different tables that we are there, the primary key informations, the time-related dimensions and measures, what is the relationships between these tables, and if any verified queries that the Cortex Analyst needs to know. Having this well documented is very important. Whatever we have discussed till now is a part of the documentation that is getting started with Cortex Analyst, augment BI with AI. I'll post this link in the description of this video so you can also go through the different steps that we have discussed till now. Basically, it gives a high level view of what is Cortex Analyst, uses of Cortex Analyst, the application that we are building, all the databases are provided here. So you can click on this Git repository. Here under the data, you can see the CSV files present for the three different tables that we had created, the daily revenue, product, region. So you can download the CSV files from here and upload it into your staging folder. And we also have a application ready available here. That is the Cortex Analyst SIS demo. Here in this application, you have the Streamlit application ready where it will call the Cortex Analyst via an API, and you can ask the questions and the Cortex Analyst will respond. Now I've copy pasted the code that was available in the Cortex Analyst SIS demo app into our Streamlit application that we had created under the Streamlit app.py. Here we are using the get active session. Basically, like it will see the get the current session. Basically, whenever you have logged in, it will get the username and the password and try to validate if it is a correct user or not. Next, we provide the semantic model parts base where our semantic model is available. That is under the Cortex Analyst demo database, revenue time series schema, raw data is our stage name, and this is the file that we have. So we can upload multiple YAML files and we can select whatever the semantic model file that we need to use for the demo purpose. And we have this API endpoint. Basically, Snowflake Cortex Analyst is hosted at this API, Cortex Analyst message, and this is the feedback endpoint. We are initializing the session, and then we have this main function. You have this sidebar and header where basically you can see the selected semantic model. Here at the top, you can see like welcome to Cortex Analyst, type your question below to interact with your data. All of them is defined under this markdown. And this is the sidebar that we had just seen, st.sidebar, select a semantic model. Here, if you have multiple, you can see a drop down. Basically, like you can connect to the stage and you can give the user an option of selecting the semantic model on the go. Next, we are creating a user input box with the default message like what is your user question. That will be at the bottom of the screen where you can see what is your question, where you can ask any different types of questions and the Cortex Analyst will provide you an output. Yeah. So basically, like by default, it is first it will ask what questions I can ask. Then it will just provide you like a brief description of the semantic model. So the semantic data model like, contains daily revenue and financial data for different products across various geographies, regions. You can analyze revenue trends, cost, profitabilities, and and various other things. And it also provides you a couple of sample questions. For example, what is the daily cumulative expenses in 2023 December? For each month, what was the lowest daily revenue, and on what date did the lowest revenue occur? And you can click on this. For example, I'm just asking daily cumulative expenses in 2023 December. So here, if you see, this was the question that we had asked, daily cumulative expenses. This is the interpretation, basically what Snowflake Cortex Analyst is understanding. So this is its understanding. What are the daily cumulative expenses? Cost of goods sold. This is the field or the important thing that it is considering in December 2023, showing the running total of expenses from the beginning of the month through each day. So here you can see the SQL query that was executed. So it is going through the daily revenue. It is taking the CO, cost of goods service as the daily COGS, and it has also provided the date conditions. You can also see if any verified query was used for generating this SQL or not. So this is one way of enhancing it. If you see like a Cortex analyst is using some other fields which it shouldn't use, then you can add it as a verified query and it will automatically next time when you ask, it will give you a correct response. And based on that, these are the output that it provided For each date, what was the cumulative goods sold? And also it provides some basic charts where you can select the x-axis, y-axis, and different types of chart options are available like a line chart and a bar chart. And you can also provide the query feedback, basically like if the response is good or not by giving up a thumbs up or a thumbs down. And you can also give a message. Yeah. So this is how you can create a Streamlit application inside of Snowflake. That's it for this tutorial where we saw how to create a Streamlit in Snowflake application using the Cortex Data Analyst. Subscribe for more Snowflake, data engineering, and AI tutorials. Like the video if you found it helpful. Comment with your questions or topic you want next. Share this with your data team or colleagues. Thank you for supporting.